Hello, we are Team 94999E Yokai, an independent team from Noonan, Georgia. We've come a long way in terms of our overall build quality and performance this season, and we can attribute our large improvements mainly to designing our robots of CAD using Fusion 360. Due to the ongoing COVID-19 pandemic, we are unable to meet with the majority of our team in person outside of specific circumstances, so we had to find a way to keep one another informed regarding our robot. Our cooperation was not the best in the early season, and we believe that showed with our robot's performance. Since we were unable to meet for planning or build sessions, the most we were able to do was just share ideas and progress, so our performance was not as strong as we wanted it to be. In the end, we resolved to become more competitive and to function more as a single, unified team.
To meet these expectations, we began using Fusion 360 to design our robot in CAD. To meet our goal of collaboration, we began saving our work in Fusion 360 Team, where we're all able to view our progress and give each other feedback for improvement. Our teammates Grace and Victoria, for instance, still haven't yet to actually physically see the robot, but they were able to give input while we were designing it in Fusion 360 and see visible progress. We were also able to set important deadlines using the calendar feature. This fall, we signed up for the Tennessee Brentwood Academy tournament on Halloween and needed to have a robot finished by then. To start, we set deadlines for specific subsystems weeks in advance to give us ample time to design, build, and program the robot. Using the easily accessible hub provided by Autodesk, we were able to efficiently cooperate when designing the robot, constructing it to the best of our abilities. After our first iterations of the robot in the summer, we decided to rebuild to make a faster and more efficient robot. We began to research other public designs as well as to put our own spin on them in our own sketches and design matrices. We concluded from our research that an X drive combined with an almost perpendicular indexer chain would make our robot much faster than our summer robot. We also decided to offset the top roller forward by about an inch to make a better angle for the ball to exit the indexer. After we had sketched out and thought through what we wanted the robot to consist of, we began to design in Fusion 360. Jacob, one of our team members, constructed the majority of the CAD, while the rest of the team gave their real-time feedback and made their own adjustments to the CAD.
By designing the robot in Fusion 360 prior to building, we ended up with a much cleaner, more competitive robot than our previous iterations. The previous versions of our robot often had excessive friction in joints, and metal often needed to be drilled in order to make sure the holes aligned. By learning how to create robot designs in CAD, we are able to design much more refined robots. We are able to verify that all holes are aligned so as to negate joint friction, as well as giving us the ability to determine exactly how long supports need to be. We can apply this to other fields of engineering as well, where designing parts in CAD is essential to making a well-constructed overall machine. As we have learned over the season, the collaboration features offered by Autodesk and Fusion 360 make for a considerably more efficient process.